Hi everyone, very good evening and welcome back to Geeks for Geeks practice. Quickly give me a +1 in the chat if my voice is clearly audible to everyone and everything is working fine. Then I'll share my screen to discuss the problem of the day for today, that is single to valued subtree. So please give me a +1 in the chat if my voice is clearly audible, and then we should start right away. Okay, so hi Rishit. Uh, right, so I think the notification has not been sent for this video by YouTube. That is why a little less people have joined. Okay, so let's start off with the screen sharing now and discuss the problem as well. Hi, Arvind. So let me share my screen now. Okay. So let's discuss this problem. The problem name is what? So the problem name is single valued subtree. Okay. The problem name is single valued subtree. Now, what is a single valued subtree? So before that, we need to see two things, right? Like the problem says single valued subtree. Okay. Now, first of all, what is a subtree? So let's say if this is a given tree, right? If this is a particular given tree, then if I start from a particular node, okay, then if I take till the bottom, okay. So let's say if I start from here and I take this much segment, so this is a subtree. Okay. Let's say if I start from this node, even that is the root node, and I take the whole till the bottom, so this is a subtree. Okay, starting from the root itself. If I start from this node, okay, and I take this whole, so this is a particular subtree, right? Is that clear to everyone? Let's say if the tree looked like this, let's say it looked like from here I'm having something, let's say here also I'm having some connection. So let's say if I start from this particular node, then this is the whole subtree. Is it clear? Is the definition of subtree clear? If this much point is clear to everyone, please hit the like button if you haven't already. Then I'll proceed further. Okay, this is what we mean by subtree. Okay, now what does it mean by a single valued subtree, right? What does it mean by a single valued subtree? So let's say the value of this node is 3. Okay, the value of this node is 3. Let's say the value at this node is 3. Let's say the value at this node is 3. So this will be considered as a subtree, okay, which is having a single value. Okay, single value. Is it clear? If inside a subtree every value is the same, then it will be considered as a single valued subtree, right? Let's say instead of this, if you're clear till this point, please hit the like button. Let's say instead of this, if I had 4 here, so now if I will talk about this much subtree, so is it a single valued subtree? Please write no in the chat. It is not a single valued subtree. Okay, and hit the like button if you are clear till this point. Is everyone clear till this point, guys? Are you clear with this point, that this is not a single valued subtree? Okay, now let's say we have been given some example. So let's say we have been given this particular example, right? So 5 1. Okay, let me draw it. So we have what? We have 5, then we have 1 here, then we have 5 here, I think, and then we have 5. Okay, let's say we have 5 here, and then we have 5 here, and then after that we have a 5 here. So I think this is how my given tree looks like. Let me see again. All right, so let's say this is how my tree looks like. So if you will see here, what I can do is, like, let's say if I start from here, what will be the brute approach, right? What will be the brute force approach for this, right? So the brute force approach is that I start from high Nikach, I start from this particular node, okay, and what is the value at this particular node? 5. Please write 5 in the chat. The value is 5. So starting from this node, I traverse the whole tree down here, okay, and I see that does every node have the same value 5? No. So this will not be considered. Okay, so you can see that from one node, from starting from this node, I iterate the whole tree. So starting from this node, I iterate through its whole subtree. So that is, I iterate through n other nodes, right? So for one node, I iterate for n other nodes, right? Starting from this node, I iterate through the whole tree. That is the concept. Similarly, what I can do is, if I want to see this particular subtree, so I start from here, I see that, okay, this guy's value is 1. So starting from this guy, what is the, like, does everyone have the same value as 1? No. So it is also not a single valued subtree, right? After this, so you can see that again for the second node also, I am doing again order of n traversal. So basically what will happen, for one node, I am traversing n other nodes to check the subtree, right? You can see that for this node, I was traversing the whole of the tree to see if they have the same value. Then for indirectly for this node also, I'm traversing the whole tree below it, subtree below it, right? Does it have the same? Does everybody have the same value, right? So for one node, if I'm taking n time, so that is why for n nodes it will take order of n square time, right? This is going to be the concept, and you can see that which subtrees are having the same value. So you can see that, okay, this subtree is having the same value. Okay, this is a single guy only. Then this subtree, then this subtree, and then this subtree, right? So total, please write 4 in the chat. There are 4 subtrees, okay, that are single valued. Okay, that are single valued, that are having the same single value. Is it clear to everyone? Please write clear in the chat, guys, and hit the like button if you are clear till this point. Is everyone clear till now? Quickly let me know, and then I'll discuss it further. Okay. Is it clear to everyone till this point? Let me take another example, right? So that we'll be more clear. So that is how you can do it using the brute force approach. That is going to be n square approach. But can we do something better than this? Can we do something better than this? If you remember one thing, you can write REM in the chat, or remember in the chat. You can write remember or +1 in the chat. If you remember that I have already told you that whenever you have a particular tree, let's say whenever you have a tree, then in such cases, whenever you have trees and you are taking order of n square time, okay, so one of the things that you can think of is that you can apply the post order traversal approach. Okay, post order traversal approach, I will tell you about it in more detail. But if you will see, just 2 videos back I have told you in the problem longest subtree sum, I've already told you this thing. You, if you remember this, you can write remember in the chat, that whenever you in a tree, whenever you are taking n square time using brute force approach, and you think that, okay, you need order of n time, so you can use the post order concept, post order traversal concept. That is, first of all, calculate the left subtree, then the right subtree, and then for the root. Okay, so basically what you do, you call the recursion and you go down, and then one by one you keep on moving up, and then you keep on building up your result. Okay, this is what you can do. Is it clear? Please write +1 in the chat if you are getting this point. This is the philosophy of the post order traversal. Okay, so that is what I am thinking of doing here. Right, now how will it work and why will it work? Let's try and understand it. Okay, so what will I do, like, okay, so what will I do? When will, like, I will also have a count. Please write count in the chat. I'll also be having a count. Initially my counter will be 0. Correct. Let me take the values from this particular tree. So what do I have? I have 5 4 5. Okay, let me write a 5 here. Okay, let me write 4 here. Let me write 5 here. Then what do I have? 5 4 5, then 4 4. Okay, this will be 4, this will be 4, right? This is going to be 5. Okay, so I think this is the tree, 5 4 5, and then 4 4 5, right? If you will see this particular tree, right, if you will see this guy, so what I will do is, like, I will have a recursive call. Okay, I will have a recursive call, or you can say that I will have a post order traversal function that will be calling. Okay, and its return type, okay, and its return type will be what? It will be bool. Okay, return type will be bool. Why will I keep the return type of my post order traversal function as bool? Because if it is returning true, then it will mean that, okay, the subtree till that particular node is a single valued subtree, and I will increase the count by 1. So I will be doing a count plus plus in this thought process. Otherwise, if it is returning a false, so it will mean that that particular subtree is not a uh, single valued subtree. So I'm returning a false. In that case, I'll not increase my count. That is the idea. So first of all, what I will do here is, basically, as I told you, this will be a post order concept. Okay, this will be nothing but a post order traversal concept. Okay, basically calculating the left subtree, then calculating the result for the right subtree, and then calculating it for the root node. Okay, so as I said, in the post order, what we do is, first of all, we calculate it for the left, then we calculate it for the right, and then we calculate it for the root. Please give me a +1 in the chat and hit the like button, guys, if you are clear till this point. Then I'll proceed further as well. Are you clear with this approach, guys, till now? Right, are you getting the idea? So what I will do is, I'll start from the root node. Okay, so I'll start from here. Now when I'm at this guy, right, so remember that the return type of my function is going to be nothing but bool. Okay, if it is a true, that means it is a single valued subtree. Okay, if it is true, if it returns true, then it will be a single valued subtree. If it returns false, then it is not a single valued subtree, right? So what I will do here is, I'll be at this guy. Now when I'm at this guy, so first of all, I'll call for the left. Please write left in the chat, guys. Everyone please write left in the chat. What I will do here is, I'll start from the root node. Okay, now I'll be at this guy. Why should we return only bool? Okay, we can also return the value of the subtree. It is not necessary. It is not necessary. Rishit, I will tell you how my idea is, such that you can do it. Okay, it is not necessary that you return the value. I'm planning to return this thing, the boolean thing, and that will also work for me. Okay, because that approach can be fine. So see, I'll be at this guy, right? Now when I'm at this guy, so what will I do? I'll go to its left. Okay, please write left in the chat. I'll go to its left. Okay, so basically, first of all, I'm going to its left, then I'll go to its right as well. Okay, now I reach this guy. Okay, Now it is 4. Okay, so I'll now go to its left. So I'll go to its left. Now I go to this guy. Now for this guy, I'll go to its left. Does it exist? Yes or no? Please write yes or no in the chat. For this last node 4, does its left child exist? What do you think, guys? Does it exist? Please write yes or no in the chat. No, it does not exist. No, it does not exist. If its left guy does not exist, right? So can I say that? Can I say that a single see? Can I say that a single leaf node, okay, will always be a single, like a leaf node will always be a single valued subtree? Please write agree in the chat. Please write agree in the chat, guys. Okay, please write agree in the chat. You all agree with me on this point that a single node, okay, that a single node will always be what? A single node is always going to be is always going to behave like a single valued subtree, right? So that is why what I can say is, when I go for this particular node, okay, for this particular node, when I go to its left, okay, since it does not exist, so I will return a true from here. Okay, I'll return a true from here. Why? Because I always want things to be like, I will return a true. I'll not increase my count for this particular true, but I will return a true here. Why am I returning a true? Indicating that okay, fine, things are fine because it is not existing, so I'll return a true. Similarly, I'll go to its left, right, okay, then I'll return from here, and I'll return a true from here as well. Okay, I'll return a true from here as well. Now once I have returned the true, okay, once my left is returning a true, okay, and my right is returning a true, right? So if you will see here, now what will happen for this particular guy? Okay, what will happen for the root? Does any of its left, like, see, can I say that if I have, like, if I have a particular node, let's say this is 5, okay, and let's say this subtree looks like, let's say this, okay, let's say this is 4, this is 5, this is 5, for a second assume this, and this is 5, okay, let's say my right is returning that okay, it is true, okay, let's say my right subtree, can I say that for this complete subtree, okay, let's say this is a subtree, for this complete subtree to be a single valued subtree, okay, can I say that the left should always return a true? Okay, left should always be a single valued subtree, as well as right should be always a single valued subtree, right? Let's say if this was 5, in fact, right? So left should always be a single valued subtree, it should return a true. Right should always be a left single valued subtree, and the left should be equal to the, like, the left data, okay, this data should be equal to the root data, and the right node data should be equal to the root node data. Okay, you can see this particular thing. Like, if I'll take another example, so let's say that instead of this, if I am changing the data like this, let's say if my left is a single valued, like if left returns a true, that okay, left is a single valued subtree, right also returns a true, that it is a single valued subtree. But if this value is 4, so this whole subtree is not a single valued subtree. Why? Because the root data is not equal to the left data or the right data. Is it clear? Right? Are you clear with this point also? This is one of the perspectives that you need to know. So what will we do here? First of all, we will simply say that okay, like for this guy, for like I'm at this particular node. Okay, so does its left exist? No, it doesn't. Okay, so I'll check for its right. Does its right exist? No. Fine. So in that case, what I will do is I'll increase my count, because this is a leaf node. Okay, so my like I will increase my count. I'll mark my count as 1. Okay, I'll increase my count, so it will become 1, and then I'll return true from it. Okay, what I will do is now I will return simply a true. Right, so let's return a true from it. Okay, I'll return a true from here. Let me write it properly. So this is, let's say L is equal to true. So left will return a true. Then after that, I go to it, this guy, and I go to its right. When I go to its right, so for this guy, does it left exist? No. So it will return what? It will return true. Please write true in the chat. I'll go to its right. Does its right exist? No. If it does not exist, then I'll return what? I'll return true from here as well. Okay, now I will check for the root node. For the root node, does its left exist? No. Does it right exist? No. Both of left and right are true. So this guy is a single leaf. So I'll say that okay, let's increase our counter by 1 more. So the counter will become 2 now. Okay, and then from here also I'll return true as well. Okay, from here also what I will do is I'll simply return a true. Okay, so now this is what right is returning. Now what will happen? As I said, first of all, the left is going to be processed, then the right, and then the root is going to be processed. So what does my left return? What does my left return? Left is returning a true. Okay, my left is returning a true. So that means that left is overall what? If left is returning a true, so this means that left is what? Left is a single valued subtree. That is why it is returning a true. Okay, and my right is also returning a true. So it means that it is also a single valued subtree. Now what should I check? What should I check? I should check that if the left guy, if for this particular current root, okay, for this particular current root, if its left child is existing, okay, then is the left, is the root, is the current root data same as the left child data? Please write yes in the chat. Is the current root data same as the left child data? Yes or no? I am saying that if left and right are returning a true, if either of them return a false, then I'll return a false. Because if you will see here, like as I said, if this is 5, okay, let's say this is what, this is 4, this is 3, and this is overall 2, and this is let's say 4, 4, and this is also 4. Okay, so if this subtree, let's say, is returning a true, okay, and this subtree is returning a false, so will this overall be a, like, will this overall tree, okay, will this overall tree be a single valued subtree? No, it will, this overall subtree will not be a single valued subtree. Why will it not be a single valued subtree? Simply because of the reason that its left is not a single valued subtree. So how can this whole be a single valued subtree, right? That is the case here. So I need to see here that is the left, like left is true, right is also true, so I'm fine with that. Now I'll check that, okay, if the, like if the left exists, okay, so I am saying that if left child exists, if the root left, okay, if the roots left exist, okay, if the roots left exist, then let's say that if the root data, okay, if it is not equal to the roots left data, is it equal to the roots left data? Yes. So if it was not equal, then I would have returned a false, but it is equal, so I'll not return a false from here. Similarly, I'll check for the right guy. So is the right guy having the, like, this is the root guy and this is the right guy, is it, are these two having the same data? Yes, please write yes in the chat, guys, and hit the like button as well if you're clear to this point. Are these two having the same data? Yes, they are having the same data. So I'll say that, okay, fine, I will not return a false from here as well. So I will simply say that, okay, in that case I can say that if my left is what, if my left is a single valued subtree, right is also a single valued subtree, and my left, this, for my this root, its left is having the same data and the right is having the same data, so that means this whole is having the same data and this whole right subtree is also having the same data. So overall, this is what, this is also a single valued subtree. So I'll say that, okay, let's increase our counter, let's mark the count as 3. Please write 3 in the chat, guys. So I'll say that, okay, let's mark the count as 3, and now from this particular node I'll return a true. Okay, so now what I will say is that from this guy, overall I'll return a true. Is it clear to everyone? Is it clear to everyone? Is it clear, guys? Till this point, if you can write 3 in the chat if you're clear till this point. So for this, left is returning a true here. Okay. Now similarly, I'll go down, like, so my left call is over. Now I'll go to the right. Okay, I'll go to the right. I'll go to this guy. Okay. Now I'll go to the right. I'll go to this guy. Okay. Now when I go to this guy, right? So now I'll go to its left. Okay. I'll go to its left. Now when I go to its left, okay, when I go to its left, does it exist? No, no, it does not exist. So if it does not exist, so what will I return from it? Please write true in the chat. I'll return true from it. Okay, and I'll not count it because it was not existing. Right, so I'll return a true from it. Similarly, I'll go from here, I'll go to the right side. Now for this guy, I'll go to the left. Does it exist? No, so I'll return a true from here. Okay, then I'll go to this guy's right, not exist, so I'll return a true from here as well. Now my left and right are not existing, they are returning a true. So that means this is a leaf node and it is also a single valued subtree. So please write 4 in the chat. Okay, now the count will become what? It will become nothing but 4. Is it clear to everyone till this point, guys? Are you all clear with this thing, that now the count becomes what? Now the count becomes 4. Okay, now since the count becomes 4, so what will I do? Since the count becomes 4, so I will say that, okay, now from here I am returning a true. Okay, so this is what I've done. So if my, you can see that left call is returning a true, right call is returning a true. So for this guy, does its left exist, guys? What do you think? Does its left exist? For this guy, does its left exist? No, it is returning a true. So it is not, it does not exist. So I cannot check, like, if this is the current root, so its left does not exist, so I cannot check with the left. Does its right exist? Yes, it exists. So it is returning a true. And is the data same? Yes. So can I say that this whole subtree, this whole region is again a single valued subtree? Yes, this whole region is also a single valued subtree, right? Because its left is returning a true, but it does not exist, so I cannot check with that. Now its right is returning a true and it exists, right child exists. So I'll say that, okay, let's compare the root data with the right child data, so they are same. So I'll say that, okay, let's increase the counter by 1 more, so the counter will become 5 now. Please write 5 in the chat. Okay, now what happens? The counter is equal to 5. Okay, counter increases by one more. Now in this case, what will happen once the counter becomes 5? So I can simply say that from here also, from this node also, since this is also a single valued subtree indirectly because its left was true, okay, and its right was also true, so this is also, and the data are same, so I'm returning a true from here. Okay, so now guys, you might think, what do you think? Like, see, you might think that, okay, what is happening? Like, my left is also returning a true for this, for this actual guy, right? For this node, you can see that its left is returning a true and its right is also returning a true. So please write tt in the chat, please write two t's in the chat. Okay, for this particular node 5, its left is also returning a true and right is also returning a true. Correct. For this node, its left is returning a true and its right is also returning a true. Correct. Yes or no? So you will think that, okay, it is a single valued subtree, but no, we cannot say that. We cannot say that properly. Why we cannot say that? Because if you will see here, like if you will see here, so what can I say? Like, I can simply say this thing, that if the left and right both are returning a true, then I'll check. Please write check in the chat. Okay, I'll check. I'll check what? I'll check that, okay, what is the current root data? Current root data is what? 5. Okay, current root data is what? Current root data is nothing but 5. This node's data is what? It is nothing but 5. Okay, what is the data of the left child? Okay, what is the data of the root's left child? Okay, it is nothing but 4. It is nothing but 4. What is the root data for the right child? Okay, right child data is what? Right child data is nothing but 5. So right child data is same, but left child data is not the same. So is it a single valued subtree overall? No, because if my left subtree and right subtree, okay, you can see that the left subtree is a single valued subtree here, okay, and right subtree is also a single valued subtree. But since the root value is not equal to the left subtree value, so I'll return a false from here. Is it clear? Since the, like, my left subtree is also a single valued subtree, right is also a single valued subtree, that is why they are returning a true. But since my root value, okay, is not equal to the root's left value, so this means that this whole overall will not be a single valued subtree, because if the left is not the same, if either of the left and the right child is not the same, then I'll return a false. Please write false in the chat. Okay, so from here, like, I can say that now from this guy I'll return a false, because this overall is not a single valued subtree, and in the end the counter is coming out to be 5. Is it clear to everyone? Please tell me, guys. Are you all clear with this? Please tell me. Then we'll proceed further as well. And hit the like button if you're clear with this idea. Is it clear to everyone? Okay. Now another concept that I will tell you, but let's write the code also so that we are more clear. Let's write a little bit of code so that we are clear with the structure of our program. Okay. So let me do one thing now. Let's try and implement this approach. So what will I do here? Like, I'll have a count. So please write count. So initially I'll have a count. Let's initialize it as 0. Okay. Then please write post order in the chat. I'll call post order. Right. I'll call it in terms of post order. First of all, calculating the result for the left subtree, then calculating the result for the right subtree, and then calculating it for the root overall. So what will I pass here? I'll simply pass the root here. Okay. And I'll also pass the counter here. And in the end, after the counting is over, then I'll return the count. So let's name it as count, in fact, so that things are more clear. Let's name this as count as well, and let's name this variable as count as well. Okay, please write post in the chat if you're clear till this point. Now please write bool in the chat also. Okay, so the return type of this function, this post order function, is going to be bool. It is going to tell me that whether the subtree till that particular point was a single valued subtree or not. If it returns a true, then it was, otherwise it was not. Please write bool in the chat, everyone, and hit the like button if you haven't already. Is it clear to everyone till this point? Quickly let me know. I hope that all of us are clear till this point. Okay, so what I'll do here is I'll pass the node, okay, star root. I'll pass the root here, and I'll also pass the count. So I'll pass it with ampersand, so that any changes that I'm making to it, they are reflected in the final answer. Now, can I say that if the root is equal to null, right? So if there's nothing, so as I said, if I'm at a particular node and I move to its left, so it does not exist. If I move to this node, imaginary node, which is not existing, so I'll return a true from here. Okay, similarly, if I move to this node, that does not exist, so I'll return a true, as I said. Right, so in that case, what will I do here? See, if this is the case, then I'll return true. Please write true in the chat, guys. Are you all clear with this thing? Is everyone clear till this point? Quickly let me know. And hit the like button if you haven't already. Okay, so this is what I'll do. I'll simply return a true from here. Now, after that, please write left in the chat. So I'll calculate the result for the left subtree. So left subtree, let's say left subtree, will be what? Bool left subtree is equal to nothing but, I'll call the post, okay, order and I'll pass the roots left child. Okay, I'll call it for the left, and I'll pass the count here as well. Okay, this is what I'll do. Now, similarly, I'll say that okay, bool right subtree is equal to what? Post order, and I'll call for the roots right. Okay, and I'll call pass the counter here. Right, now once this is done, so see, if you need to see this thing, right, as I said, there's one more case that you need to figure out here. So let us say that if either of them returns a false, what does that mean? So let's say this is 5, okay, and let's say this is 4, okay, let's say this is 3, and this is overall, let's say 5, okay. So if this is my left, okay, if this is my left, let's say this is my left, okay, and suppose the right looks like something like this, okay, let's say the right looks something like this. So if this is my right, okay, if my right is returning a true, okay, let's say my right returns a true and my left is returning a false. Why is it returning a false? Because my left is not a single valued subtree. Okay, please write not in the chat. My if my left is, suppose that my left is returning a false, so that means my left is not a single valued subtree. Okay, if my left is not a single valued subtree, so can this whole tree be a single valued subtree? No, please write no in the chat. Suppose that if my left, like if you are having this particular situation, okay, and in this particular situation, what is happening with you is, like, your, let's say your right is returning a true, okay, it says that, okay, your right subtree says that, okay, I am what, I am a single valued subtree, okay, and then your left subtree is returning a false, it says that, okay, I'm not a single valued subtree. So in that case, will this whole subtree be a single valued subtree? Please write no in the chat. No, it will be not, it will not. If my left is not a single valued subtree, then my whole subtree, this whole will not be a single valued subtree. Okay, if you have one dirty fish in your pond, then the whole pond gets dirty, right? So that's the concept here also, that if my left is returning me a false, right, if my left is not a single valued subtree, then in that case this whole subtree cannot be a single valued subtree, right? So in that case, I'll say that similarly, let's assume this case also. Let's say that if I have a case like this, let's say this is 5, okay, let's say this is 4, okay, let's say this is 3, okay, let's say this is 2, let's say this was 5, this was 5 again, okay, and this was 5 again, right? So let's say that this left subtree returns a true and your right subtree returns a false. Okay, so if your right subtree is not a single valued subtree, so can this whole be a single valued subtree? Please write no in the chat. If my right sub, like if my right also, maybe if my right returns a false, right, if either of them return a false, right, then it will not be a single valued subtree. Or it might happen that, okay, my left is also returning a false. Okay, left is also not a single valued subtree, right is also not, in that case also. So if either of them is false, then I'll return false. Is that clear to everyone? That if it happens that my left subtree, okay, left subtree is not a single valued subtree and it returns a false, or if it happens that my right subtree, okay, if it returns a false, so if either of my left subtree or right subtree is not a single valued subtree, then this whole subtree for this particular root node will not be a single valued subtree directly, so I'll return a false directly here. Okay, this is what I'll do. Okay, this is what I'll do. Now otherwise, what will I take? Otherwise, I'll check that, okay, suppose if my left returns a true, okay, as I said, now what will I take? See, if I have 5 here, okay, let's say if I have let's say some notes, let's say this is 5, this is 5, okay, and this is 5, not or, okay, not or, put and, no, I need to put or, na, like if either of them is false, then it will be false, right? So that is why I'm putting, right? So suppose that this value is false, okay, this value is false, this value is also false, right? So sorry, this is 4, this is 4, this is 4. So if it is returning a true, okay, suppose this is my root, okay, now this is the left guy. So if my, suppose that if my left is returning a true, obviously then I am down, okay. So if this returns a true, so if the root data is not equal to the roots left, okay, so this, like, even when my left returns a true, but if the root data is not equal to the root left data, so in that case also this whole will no longer be a single valued subtree. So I'll say that, okay, if the roots left child exists, okay, if it happens that my root for my root, if the left child is not equal to null, okay, if it's not equal to null and the root's left child data, right, if it's not equal to roots data, right, so in that case also I'll return a false. Please write false in the chat. In this case also I'll return a false, right? Because even when my, if my left guy, suppose that my left guy is a single valued subtree, Okay, but my left guy is not having the same value as my value, then I will no longer be a single valued subtree. Are you getting this? Please write getting in the chat or yes in the chat. And if you're clear till this point, please hit the like button if you have just joined now. Are you all clear with this? I'm getting some ads on my video today. Okay, right, this is what I'll do. Now similarly as I said, so let's say that this is 5. Okay, now let's say that this was 5. Okay, this was 5. Okay, this was 5, this was 5. So let's say this was 4. Okay, this was 4. Okay, this was 4. Now if you will see here, let's say this whole subtree is what, like it is returning true. Now you check for the root data and the left data, they are same, so you'll not return a false. But now let's say your right subtree is a single valued subtree, so it is returning a true. But you check that, okay, root value is not equal to the root value is not equal to the right value. Okay, root's right child. Okay, so if the root value is not equal to the right child value, so this whole will no longer be a single valued subtree. So in that case also I'll return a false. So I'll say that, okay, if it happens that the root's right child exists, okay, if the right child is not equal to null, okay, if it's not equal to null and the root's right guy, okay, data, if it's not equal to roots data, right, so in that case also I'll return false. Please write false in the chat if you're clear till this point. Is it clear to everyone? Is it clear to everyone? Please write clear in the chat, guys. Then we can proceed further also. Okay, so this is what I'll be doing. Now in all other cases, I'll say that, okay, I'll return a true. So before returning true, I'll do count plus plus. So please write count plus plus in the chat. Right. Otherwise, I can say that if I have checked for all these edge cases, that if my left is not a single valued subtree, or the right is not a single valued subtree, or even when my left and right are single valued subtree, but if the left data is not equal to the right data, or if the right data is not equal to the root data, right, if the root data is, sorry, if the left data is not equal to the root data, or if it happens that the right child data is not equal to the root data, okay, so in either of the cases it will no longer be a single value, so I'm returning a false. Otherwise I'm incrementing the count, and for this subtree I'll return a true. Is it clear to everyone? I hope that this is clear to everyone, right? Is it clear? Please write clear in the chat, guys. Now let's try and compile this also to see if it works or not. I'll try to compile it. Okay, so it works on the samples. Please write works in the chat. It works for the samples, right? Please give me a +1. Now let's try and submit this code as well. Hopefully it should get accepted as well. Okay, so it gets accepted. You can see that I have submitted it for the 5th time. So I've been solving this problem for quite a long time, and it gets submitted, right? So please write +1 in the chat if you're clear with this problem. This problem gets accepted. Okay, you can see that I've submitted it so many times. I submitted it last time in May 2022. Then now I'm submitting. So if you're clear with this problem, please give me a +1 in the chat, and then I'll proceed further with this problem, right? So you can see here that by doing this, what I did was, overall, if a particular tree was given to me, right? If a particular tree was given to me, so what did I do? I can basically say that if this tree was given, so basically I went down, okay, then I went up, right? Now to be precise, in the worst case, if this kind of a tree was given to me, right, a single skew tree with n nodes, so I went down, okay, and then I went up all the nodes. So basically I can say that the time complexity is going to be what? It is going to be nothing but order of n, because I'm traversing each node exactly once, right? And the space complexity in the worst case, if I'm using recursion here, that is nothing but the post order traversal is a recursive function. So the recursive stack space in the worst case will store all the n calls, right? So basically this will be nothing but order of n stack space as well, recursive space. So that is why the time complexity is order of n, and the space complexity for my approach is also order of n. Is it clear to everyone? Please write clear plus plus or understood in the chat if you're clear till this point, and hit the like button if you haven't. Guys, hit the like button if you haven't already. Okay, I hope that this makes a lot of sense to everyone, right? Is this problem clear to everyone? Quickly let me know. You can hit the like button and tell me if you're clear with this. Okay, so basically this is what I've done. Again, I would revise it for you, right? So basically I had the counter. So initially I marked the counter as 0, right? Then after that I ran a post order traversal approach. So basically in these approaches, first of all I'll calculate the result for the left subtree, then I calculate the result for the right subtree, and then I calculate it for the root node. Okay, so basically I'll pass the root, I'll pass the counter, and in the end I'm returning the counter, that is the total number of single valued subtree, right? This function will have, post order function will have a return type of bool, because it will tell that, okay, if a particular subtree is a single valued subtree or not. So if I reach the root node, If the root is null, then I'll simply return true, because I have to, because a leaf node will always be a single valued subtree. Okay. Then I'll calculate the result for the left. Please write left in the chat, everyone. Then I'm calculating the result for the left subtree. I'm calculating the Boolean result, that whether or not my left subtree is a single valued subtree or not. And I'm similarly calculating whether or not my right subtree is a single valued subtree or not. Okay. Now after this, what I'm doing is, if my left subtree is not a single valued subtree, then the whole subtree cannot be a single valued subtree. Similarly, if my right subtree is not a single valued subtree and it returns a false, then I will return false. So if either of them, if both of them are not single valued subtree, if my left subtree is not a single valued subtree, or my right subtree is not a single valued subtree, okay, or both are not single valued subtree, then the whole subtree for this particular current root will no longer be a single valued subtree. So I'll return a false from here, indicating that, okay, it's not possible. Otherwise, I'll check that, okay, if my left subtree is a single valued subtree, but my left exists, and it happens that the left data is not same as the root data. So as I said, that if suppose that I am having this node 5 and my left is a single valued subtree, okay, if it is a single valued subtree, but if the left guy is not having the same data as me, then I'll return a false, because in that case this whole subtree, suppose that there were some other nodes here also, this whole subtree will no longer be a single valued. Similarly, if I'm having a 5 here, okay, and let's say if I'm talking about the right, so if my right guy is a single valued subtree, but it is not having the same, it is existing and it is not having the same value as me, right, as a root, so in that case also I'll return a false. Otherwise, I'll do the counting, so please write count in the chat, and then I'll return true in the end. So is this point clear to everyone? Please tell me, guys. Is it clear? Please write clear in the chat, guys, if you're clear till this point. Is everyone clear with this idea? Please write clear in the chat and hit the like button. Okay. Rishit says clear. What about others? I hope that everyone else is also clear with this idea. You can see that the time complexity, as I said, in the worst case will be order of n. Space complexity will be order of n. And this question, you can see that was asked in media.net. Okay, so it is a very good company, to be honest. This question has been asked in Amazon as well, I think. So primarily, this question was asked in media.net. Okay, so if you are clear, you can write clear in the chat. And I hope that this approach is clear to everyone, and you will take this approach with you after this video is over as well. Is it clear to everyone? And you can also read in which companies this was asked as well. So you can see that it was asked in 2 to 3 years experience to people. Okay, is it clear to everyone, guys? Quickly let me know and hit the like button if you haven't already, and then I'll end this stream as well. Okay, so right, you can hit the like button if you haven't already. Okay, so this was the problem of the day. Thanks a lot, everyone, for joining in, and make sure to solve it on your own as well. And I hope that you will remember this post-order traversal approach, which helps you to solve the trees problem in order of n time. Last time also, when we discussed the problem of the day for Wednesday, then also we discussed the problem where we did longest subtree size, subtree sum in order of n time, right? You should remember that also. So thank you for joining, and make sure to keep coding, guys, and make sure to keep solving the problem of the days. Till then, please make sure to hit the like button and comment down understood after this video is over, and keep coding. Thank you for joining, and good night, everyone. You can write a +1 in the chat after this video ends. Thank you.